Hey, Year 12s, how's it going, guys? I've deliberately been late. I've been on the chat, as you can clearly see. I mean, obviously, I dabbed on the chat there. I've just been waiting for everyone to get done, so I don't have to faff around with the register quite so much. I mean, obviously, let's get rid of that. Pause that one. I've just had Aisha show up, and I think Emmeline. Did Emmeline make an appearance there? No, Isha. Isha and Aisha. That's good. Let's do Aisha. No Anch yet. No Anch, Murdo, or Emmeline. Though, oh, there's Anch. Just arrived. You are a bit late there, Anch. I don't wonder why. I'm curious to whether or not another lesson overran or something. So just Emmeline and Murdo now missing. I will leave that there and we can crack on with the lesson. So I'm going to go through the homework first of all, guys. Share screen. Let's crack on. So today we're going to go through the ideal gas homework and then we start. Sorry, I forgot the lesson starts at 11:15. Yeah, fair enough. Noise. Hide. We're going to go through the ideal gas homework and then we're going to start work on reacting masses and bringing you up to the A-level standard. The homework's going to steadily get harder and far more realistic as we go into this, because I think you guys all realize that these came straight out of A-level papers. Yeah, these, I have literally cut out the ideal gas bits that you could then run based on the lessons that we've done so far. I was very aware that the homework that we did previously was very tough, but let's run through these and see how you guys get on. Okay, so a second sample of nitroglycerin was placed in a strong sealed container and detonated. The volume of the container was 1 dm cubed. The resulting decomposition produced a total of 0.87 moles of gaseous products at this temperature. Use this to calculate the pressure. Right, ideal gas equation, PV equals nRT. We're okay with this. We get used to using pervert. Right, so let's now just select our data. Pressure is what we're trying to calculate. Now, guys, you must reorganize. Whenever you do any calculation, there's always a mark for reorganization. So we need to do P equals nRT over V. That's what we now need, because as soon as it says that's a reorganized mark, you must do it. Now we need to just check our data. N equals 0.873. R, of course, we've been given equals 8.31. Temperature, which they've been nice and given it to us in Kelvin. No conversion needed. But the volume is the tricky bit. They've given us 1 dm cubed, but we all here know that we must put it in meters. Now, I didn't really talk to you guys about this conversion enough in the first lesson. I told you guys that 1 meter cubed equals 1,000 decimeters cubed, which equals to 1 million centimeters. But I didn't do any examples of conversions. So if we're going to go from dm to meters, we're going to divide by 1,000. Yeah, so I need to divide that by 1,000. So that just becomes 1 times 10 to the minus 3. 1 times 10 to the minus 3 meters cubed, because I went from dm to meters cubed. Okay, there's my numbers. Let's insert them into my calculator. P equals 0.873 times by 8.31. I'm going to shrink my pen as I think it's too fat. Times by a temperature of 1100, all over 1 times 10 to the minus 3. And the pressure is going to be spat out in pascals, remember. Yeah, so 0.873 multiplied by 8.31. I'm looking at my calculator all the way through this, times 1100 divided by 1 exponential minus 3. Sorry, Emmeline. And that gives us 7,980,093 pascals. If you want to put it into kilopascals, it's 7980 kilopascals to 3 sig fig, which is amazing. Amazing. So there's my first answer. Ticket if you got it, folks. Now, just to let you know, in realistic cases, so I can't remember. Oh, my laptop's having a bit of a breather. It's nice just to mention, do you know what? I'm going to mark this as if we're in an A-level exam. 4 marks. Going to make my pen a bit thicker for this bit. So 1 mark for that bit, 1 mark for the rearrangement, 1 mark for the conversion, and 1 mark for the final answer. There's the 4 in its entirety. Check it if you got 4, folks. Next. Okay, so a 1 gram sample of potassium nitrate was heated strongly until it fully decomposed. Calculate the number of moles in 1 gram of, grams over rams, that's nice. Number of moles is grams over rams, and they've even, I hate them when they do that. I'll tell you why, because they had too many marks. If they've got a less mark, they would have taken that away and made you calculate it. Yeah, this literally is 1 over 101 point. This is not A level. Come on, Edexcel. Get with the program. 9.89 times 10 to the minus 3. I'm keeping it on my calculator. There's my moles. Next. Okay, at 298 Kelvin and 100 kilopascals, going to have to convert the kilopascals, oxygen gas produced in the decomposition occupied this, and they've given it to us in meters cubed. Perfect. Ideal gas equation, PV equals nRT. Moles of oxygen reorganized for N. PV over RT gives me N. I'm just dividing both sides by RT. I hope you guys saw that. It's not rocket science, is it? Yeah, that's why I love pervert so much. I don't teach it anyway. Some people actually teach PV equals RT equals moles. And I do understand that because moles is grams over rand, moles is C times V over 1,000, moles is PV over RT. But I just like to do pervert because it's easy to remember. Yeah, so so it just says calculate the number of moles. So just insert my data. The pressure, we've got to remember to convert. So let's do pressure is now equal to 100,000 because lots of people forget to do that conversion. You must put it in pascals. Yeah, the volume, we've no need to convert because they've already done it for us. Times 10 to the minus 4 meters cubed. That's perfect. Next, we know R is 8.31, and we know that the temperature was also in Kelvin. That's rather nice of them. Yeah, that's great. Lob them into my calculator. Yeah, so 100,000 multiplied by a volume of 1.22 times 10 to the minus 4 all over 8.31 times by 298. You can see where the marks are coming from again, can't you, folks? 100,000, count my zeros. Yeah. Times by 1.22 exponential minus 4, sorry, Emmeline, divided by brackets 8.31 multiplied by 298, which gives me an answer of a moles of 4.93 times 10 to the minus 3 moles. And I'm done. Tick it if you got it, folks. Let's run through my marks. Yeah, the marks is 1 for that bit, 1 for the reorganization, 1 for the conversion, and 1 for the final answer. 1 meter cubed equals 1,000. Yes, that's correct. That's correct. Yes, spot on. So in year 12, are we going to do everything we have done so far again? Well, if it depends what side I'm teaching you, Anch, actually. Because if I'm teaching you Unit 2, you're doing calculations with Miss Childs. Or otherwise, we'll probably have to redo it and you'll just be that much better at it, Anch. Yeah? But I don't like saying that because it means that you guys don't listen. Ha! Oh, it's 5. This one's 5 marks. Have you noticed? This one's 5. Ooh, don't know why. Only got 1 conversion, 1 reorganization, final mark, don't know. I'm not going to give it 5, I'm going to give it 4. There you go, folks, giving it 4. Pressure? Yeah, there was the conversion, did the conversion, conversion's there. Yeah, that's the conversion mark. Reorganization, conversion, yeah, it's fine. Next. I'm going to give you 4 out of that, not 5. Oh! No. Ignore me. I'm an idiot. Previous question. 1 up there. I'm an idiot. Just ignore me. Because I don't understand everything we have done so far, so that's why I was asking. And you just need to keep watching my videos. Watch them back again, or give me a call on Hangout and I'll go through it. The A section is a mark. Yeah, thanks, Manisha. I spotted it when I zoomed out. I was like, found it. Next. Okay. Ideal gas equation. Again, I'm just going to rub it in. Hang on. Put it in red. I like it being in red. Yeah. PV equals nRT. Yeah, just got to learn that, Ansh. That's once you just got to, don't forget, like and subscribe. That's really funny. Give Mr. Duncan the bag. I don't really know what that means. Total number of moles of gas, right? So First of all, it's moles again, same reorganization, PV over RT. Right, check my numbers. Where's temperature? I've got to convert 227 degrees Celsius, add 273 to get it to Kelvin. Do that straight away, 227 plus 273. Check my calculator. Wow, exactly 500 Kelvin. That, by the way, means I'm on the right lines, just so you know. Give money the back means cash money, sir. Yeah, do you know what, Adam? I don't think I will ever say in a webinar, like and subscribe. It's just not me. Yeah. There's the temperature. Next one, the pressure also needs converting. 100,000, 2 marks for the conversion, although Edexcel will probably just give you one singular one. And then the volume, of course, they've given you in meters cubed, 1.5 times 10 to the minus 4 meters cubed. So they're not 3 conversions, but 2. Yeah, we know what R is. It's given to us. Let's run them in. Yeah, so pressure is, so number of moles equals 100,000 multiplied by the volume, 1.5 times 10 to the minus 4. All over 8.31 multiplied by the temperature, which is 500. 100,000, count them on my calculator, multiplied by 1.5 exponential minus 4, divided by brackets, 8.31 multiplied by 500. And I get an answer of moles of 3.61 times 10 to the minus 3 moles. We're done. I like it. So in that answer there, yeah, technically the marks are going to be 1 there, 1 for the rearrangement, 1 for that one, 1 for that one, and 1 for the final answer. So 5 marks again. 5. I like it. Next, let's try and get through these as quick as possible, shall we? Will help Mr. Duncan say. His Yit channel. I don't quite understand what you guys mean sometimes. I'm such a boomer. I'm going to post it on the chat anyway. You're so funny. PV equals nRT. Moles of ammonia. Right, number of grams, gaseous ammonia. Number of moles is grams over rams. Yeah, we've got 0.143. Notice they did not give you the formula for ammonia. Ammonia's MR is 17.0. Yeah, over 17.0. If you've forgotten the 0, you lose 1. There's your first mark, guys. Yeah, that will there get you a mark there. Run that through your calculator. 0.143 divided by 17.0, and I get an answer of 8.41 times 10 to the minus 3, but I'm keeping it on the calculator. There's my moles. Right, calculate the value for the temperature. Reorganize for T. So T equals PV over NR. Yeah, over NR. That's why you can't use triangles, A8. I have made 5 accounts and subscribed with all of them. That's hilarious, Ange. That's a joke, right? Please tell me that's a joke. But hilarious. So, pressure. Where's my pressure? Needs to convert. P, 100,000. Yeah, there we go. Converted straight away. V, what's my V? It's in meters cubed. No conversion needed. 2.86 times 10 to the minus 4. What's my N? I've just got my N, but I used the number on my calculator. 8.41 times 10 to the minus 3. That's the clever trap here. You've got it. No, I actually did. That's brilliant. My final email address of my BS kit will be like and subscribe to Mr. Duncan's page sent to the whole school. I'm going to say don't do that. It's fine. 8.31. The trap, that there is the trap. Yeah, that's the trap, because people are going to use the rounded figure they did from the previous bit. You can't. You must use the one that's on your calculator. So let's now run it through. Yeah, 100,000. I'm just going to do it straight on. No, I'm going to write it down anyway. I always like to. 2.86 times 10 to the minus 4 over moles. 8.41 times 10 to the minus 3, but it's on my calculator, times by 8.31. So what I'm going to do is I'm going to do this bottom number first. That's what I'm going to do, because I've got this whole number on my calculator, multiplied by 8.31. Ooh, 0.31, there we go. So that now gives me a new bottom number. Yeah, so I can just go 0.06. Oh, isn't that fascinating? Rounds to 700. That's interesting. So this bottom number there becomes just 0.077. I've got the whole number on my calculator though. Then what I'm going to do is I'm going to go brackets 100,000, count my zeros, times by 2.86 exponential minus 4 divided, close brackets, divided by answer. That way I don't lose my rounded figure. Yeah, and the answer is going to be spat out in Kelvin. 409 Kelvin is my final answer. So let's check your marks. Check your marks. 1 mark for that one, 1 mark for the AR, 1 mark for the moles, 1 mark for the rearrangement, 1 mark for that conversion, and 1 mark for the final answer. 6 marks in total. Oh, that's interesting. They've awarded 4. Isn't that fascinating? So what they're doing is, guys, they are lumping together two different marks. So what they're saying here is, in order to get these two there will go together. That there, without this, so if you miss the 17.0, you will lose that mark. That there is 1 mark. And that there is one of the most lost marks because students forget the 0. The calculator makes it disappear. We're going to get you the bag, sir. Okay, Adam, I love it. I won the bag. You help me get the bag. Amazing. So that becomes 1. So instead of then 6, the next thing is the conversion step will go with the rearrangement. Yeah. So 1, 2, 3, 4, 5. Yeah. So that rearrangement and that conversion will be worth 1, just so you know. Do I lose the mark if I wrote 400? No, absolutely not. You will get the Alistair. That's absolutely fine. It didn't say in the question to give it to a certain number of significant figures. You tend to always give it, what I always say is the rule of thumb is you always give it to 3, but they won't discount, they won't mark you down for that, Alistair, at all. It's a good answer. Well done. Next. Right. We're getting used to this. And do you see why I wanted to set this as a homework? Because you guys have been using V over 24 for 2 years. I'm now trying to delete that and overwrite that data with PV equals nRT. Yeah, so it's good to get you to do this and write it down every single time. It's good, good reinforcement. Yeah, what's it going to ask me to calculate? Oh, this is my favorite question by far. Calculate the relative molecular mass of A. Okay, that's genius. We can work out moles. So what we're going to have to do is we're going to rearrange this one for moles. Number of moles is PV over RT. Because what this equation is, this one is going to spit me out with moles. Because if you want to calculate relative molecular mass, you need number of moles is grams over rams. Yeah, and look, it's going to give us grams. There's the grams. We need moles. This is the best question so far. Yeah, really like this. So number of moles, the pressure. Where's the pressure? Okay, it needs to be converted. So 103,000 pascals multiplied by the volume. Aha, they're so mean. So the P has been converted. The V, which is 127 centimeters cubed, divide it by 1,000,000. Holy mackerel. Yeah, so that's just going to be, so 127 divided by 1,000,000, count my zeros, 6 zeros, done. So I get 1.27 times 10 to the minus 4. That's a big conversion. Very common, actually, at A level, because chemists work in centimeters cubed. We are going to measure a decimeter. It's stupid. Yeah, so the volume is 1.27 times 10 to the minus 4. If you don't like doing that maths on the calculator, by the way, another trick that I often show people is just, if you ever have centimeters, just put times 10 to the minus 6. It's just another easier way that I often offer students. 8.31 multiplied by a temperature, which is in Kelvin already, which is really nice. So that's okay. I'll lock those in. Okay, so 103,000, count my zeros, multiplied by 127 exponential minus 6. Okay, divide that answer by brackets 8.31 multiplied by 415. And I get a moles of 3.79 times 10 to the minus 3. Now, because I've got a second equation coming in, I don't want to lose that number on my calculator. Number of moles equals grams over rams. Let's reorganize for rams. Bring the rams over. Number of moles times by rams gives me grams, and then bring the moles down. Bid mass, yeah, over moles. There we go. There we go. So I need to do 0.304 divided by 3.79 times 10 to the minus 3, but I'm going to use the actual number on my calculator. 0.304 divided by answer. And I get a relative molecular mass of 80.1. And there's my answer. Lovely question. That is sexy chemistry right there, folks. That's what that is. Sexy, sexy chemistry. 1 mark, 2 marks, 3 marks, 4 marks. There was a conversion step as well for the pressure. Yeah, and then grams over rams, and then 1 mark. 5. I've got 6. Okay, so the 2 that are going to be converted is the 2 that are going to be included are the pressure and the temperature combined. Sorry, pressure and volume. Yeah, with pressure and the volume, that conversion and that conversion will be included in a single mark for 5. 5 marks. Good question though. What a lovely, lovely gas question that was. Sexy, sexy chemistry. Let's go for the next one. Okay, give the name of the equation. Ideal gas equation. I like it. Notice, by the way, that the P is lowercase. You're allowed to do that if you want. I don't tend to. Don't ask me why. I don't really know. It just is. Go figure. Okay, use the equation to calculate the number of moles. So there's going to be a rearrangement. Number of moles equals PV over RT. Yeah. Next, calculate the number of moles and the sample of relative molecular mass. So hang on, I've got data. Oh, okay, and hence the relative. It's the same kind of thing. I like it. So let's run our numbers in. So pressure, where's pressure? Got to convert. Yeah, so number of moles equals 110,000 multiplied by a volume. 2.34 times 10 to the minus 6. Do you see how easy that is when you get centimeters cubed? You just got to be careful in case you get DM, because then it's 10 to the minus 3. Just watch out. Yeah, over R, 8.31 times by a temperature in Kelvin, which I don't need to convert, 473. Run it through my calculator. 110,000, 110, yeah, multiplied by 2.34 exponential minus 6, divided by brackets 8.31 multiplied by 473. Next, and I get a number of moles of 6.55 times 10 to the minus 5. Tiny moles. Tiny moles. Right, number of moles equals grams over rams. Reorganize, bring rams up, bring moles down. Rams equals grams over moles. Where's my grams? Got a tiny grams, 0.406 over moles of 6.55 times 10 to the minus 5. It's tiny moles. I feel like I made a mistake somewhere there. Yeah, so let's see what it does. 0.406 divided by answer. I've made a mistake somewhere. Somewhere there is a mistake. I don't know where. I've made a mistake. So I'm out by a liquid. When a sample of liquid was vaporized, the vapor was found to occupy. What have I done wrong? I've got my moles is out. 10 to the minus 6. There's going to be an error here somewhere. I got the same as you for the last question. Oh, interesting. It means they've either done it deliberately to freak people out. Yeah, it could be a polymer. It could be a plastic. Tiny moles. I know, tiny moles, right? Either that or there's an error in the number. There could be an error in the number. There could very well be an error in the number. I'm not really too fussed, to be fair. Your answer's good. 6,200. It could have been a liquid polymer. Yeah, it's totally possible. Most polymers, of course, aren't liquids. That there is that has an MR. Oh my God, that's the RMM. That is not a liquid, guys. That will be a solid by a mile. They're doing something deliberately. The follow-on question. See, I've cut all of these sections out of papers. The question C will say something like, suggest why this MR suggests that it's a polymer, and you'd say because polymers are giant molecules made of millions of repeating units. And then it'll give you the MR of a unit and say, work out the number of repeating units in your liquid. That's what it's going to have been, something weird like that. Not that it matters. I'm going to give you the marks for it anyway. If you've got the same answer, I'm correct. It's good. 1 mark for that one. 4 marks. 1 mark for the rearrangement. 1 mark for the conversion there. Yeah. Rearrangement again. RMM. Yeah, and moles. I'll give you it for that one. 2 conversions in 1. Yeah, those 2 conversions there, guys, are both going to be worth 1 mark in total. Total marks for that one, of course, is 4 and 1 above it. Amazing. That brings us to the end of the homework, I believe. It is going to have been a polymer. It's definitely going to have been a polymer. What's it out of? I don't know. So we've got 4, then we've got 5. So that's 9. 9 plus another 9. So 18. 18 plus, and this is 10. Look at that. So out of 28, guys. So out of 28, input your data. Amazing. Input your data out of 28. A liquid polymer. Yeah, Adam, I knew you were going to say something like that. Yeah, so, PVA glue. Everyone knows PVA glue, yeah? Polyvinyl acetate is what it stands for. Yeah, or polyvinyl alcohol, depending on which one you actually have. But polyvinyl acetate is a polymer which is soluble in water. And what you can do is you can do a reaction, and that's giant molecules suspended in water because it makes bonds with water. So you can have a polymer dissolved in water, and that's probably what they've done here in this particular scenario. So thank you for somebody filling in the little gap at the top. Appreciate that. I'll see if I can square it up. I really enjoyed that homework. I thought that was really nice. Really enjoyed it. That was fun. See if we can shrink that down a bit. There we go. I'll color code it. Do you notice that I color coded your results, by the way? Oh, it's nice to see other people's data going in. Wow, Misha, well done. 12, good score. Adam, 9, good score. Everyone is doing really well. It's interesting seeing the level of difficulty increasing, though. It is nice that. Just going to try and color code some of these things, just trying to be consistent across it, make that into the purple. Yeah, I think today's lesson might be, I might not do the reacting. Also, burn duct tape in my free time. What? And I also burn duct tape in my free time. I probably wouldn't want to burn duct tape, you know. It's not going to be nice, that. That's going to be a PVC of some variety with chlorine molecules, and you'll be making all kinds of organochlorides. Yeah. Things like that's annoyed me, that. Toxins, chlorotoxins, I can't remember what they're called. Dioxins, can make a whole load of dioxins. Wow, look at these scores. Guys, I am impressed. Wowzer. Wow, you guys have seriously kicked. Oh, I didn't say anything. You guys have done really well on that. I am super impressed. Well done. Absolutely smashed it out the park. Well done. Seriously impressed. Wowzer. So, okay, you guys can do gas equations. That's nice. Like this. That's excellent. I feel like with notes, that Idealgas homework was okay, but without them, I'd be much more likely to get it wrong. Yeah, that's fair enough, Adam. Obviously, you do need to get to the point where you can do it without your notes, but this is a reinforcement homework. And you're probably going to have to redo all of these anyway when you go to school the next time. Angel, outstanding, 24. What a great result. That's really good. God, you guys have absolutely smashed this. Wow, I'm so impressed. I lost a lot of marks on the last question. Sorry. Don't say sorry to me, Angel. You never, ever need to say sorry to me. Are you joking? Angel, you got 86%. Don't be giving me a sad face for 86%. No way. Not allowed. You guys have smashed that. Well impressed. Okay, let's move on. I like it. Okay, guys. Oh my goodness, and here comes the big one. Reacting masses. Blimey. Okay. Right, guys. So, reacting mass. Now, this is the one that... This actually isn't the hardest one, by the way. Excess reagents is the hardest in reality. But reacting mass calcs. Now, I'm teaching this as if I'm teaching a GCSE lesson in reality, because I don't know where you guys stand. I don't know where you're all up to. I don't know whether or not you guys have got good procedures in place. So I'm going to be teaching, don't get me wrong, I'm going to do it at a fast pace because you guys should have already done this before. Yeah, so what I'm going to do is I'm going to be teaching, the first bit is the GCSE bit. GCSE. So, okay, so here's the GCSE question. Yeah, question number 1. They say sodium reacts with oxygen to form sodium oxide. Yeah. There's your equation. And it will say Adam reacts 10 grams of sodium with excess oxygen. With oxygen, they won't even give you the word excess, you have to just make an assumption. With oxygen to make sodium oxide. What mass will he make? Yeah, mass will he make? So this is a very straightforward, typical GCSE question. So the question is why is this GCSE? Yeah, and the key thing here, there's a couple of points. Number 1, so why GCSE? Why is this not A-level? Okay, first reason. Sorry, hang on a sec. First reason, they've given you the equation. Yeah, you are not going to be given equations anymore. The equations are going to be down to you. All they're going to do is give you that now. And the first step that you must do is to write a balanced equation. Step 1 at A-level. Yeah, write balanced symbol equation. Right, balanced equation. Yeah, first step. And God, what a step up that is from GCSE. Students hate equations. It's because chemistry is a language, and I get it. I really do. I really, really do. And the longer I've been teaching it, the more I've realized that it's a language. Yeah, but I understand why that's always tough. The next thing is, why is this GCSE? Actually, that's kind of the only reason. They're making you write the balanced equation at the beginning. By the way, that question there is GCSE because of the equation. As we move forward, I'll show you what happens as we step into A-level. So let's now run the steps for this. Step 1, write a balanced equation. Step 2, I'm just giving you these for your notes, guys. Yeah. Is the best at practicals, that's why. I see. Write balanced equation. Step number 2, get to moles. Get to moles. So what this means is now for you guys, get to moles means that you're either using grams over rams, you're either using number of moles equals C times V over 1,000 if you're in centimeters cubed, or you're using PV equals nRT, whichever one is needed. Yeah, in this case, we're using grams over rams. Yeah, this is what flags up our equation, the bits of data in the question. Yeah. Once we get to moles, step number 3 is use the ratio. Use the ratio from the equation. So in this particular equation here, of course, I'm going to highlight the ratio in green. Yeah, so this is a 4. I'm going to actually do this in a highlighter pen, I think. 4 to 1 to 2. There's my ratio. Yeah. And then finally, step number 4, don't want it to be in green for consistency. Yeah, step number 4 is get out of moles. Out of moles. This will be a rearrangement of some type. Yeah, rearrangement. This is not complicated. Yeah, okay. So let's run this particular example. Yeah, and I'm going to run all those steps in this tiny space next door. I'm going to do it in blue. I'm going to run all of those steps right here. Yeah. So step number 1 has already been done for me because it's GCSE. Step 2, get to moles. Yeah. So step 1, I'm just going to go S1, done. S2, I'm going to go, right, number of moles is grams over rams. I always write down that equation in case it's worth a mark. 10 over, now we are now, of course, at A level. So the sodium now gains an extra level. So we now need to just check on the A-level table what sodium's is. Yeah, let's find sodium, 23.0. There it is, 23.0 for sodium. So we go over 23.0. So easy to lose that mark. Do watch out. Let's run it through my calculator. All I'm doing is getting to moles. Grams over rams over 23, and I get 0.435 to 3 sig fig, and I will write down moles of sodium. Right, okay, now step number 3, use the ratio. So the ratio, which I will then again do in green, and you must write this down. This is worth a mark, folks. Yeah, 4 to 1 to 2. There's my ratio. Now, what I was given sodium. I'm going to do this here. I was given sodium, and that's what I've calculated, and I'm trying to get to sodium oxide, which is there. So my ratio is, in fact, 4 to 2. I don't need the 1 in the middle. To do that, it's a divide by 2 step. Now, some of you guys may have learned this type of calculation in a table format. That now needs to be deleted. The table format is not allowed. You need to be able to show your understanding of moles and ratios, and if you don't, you will lose the marks. So I go back to my moles, yeah, which is 0.434782608, and I'm going to divide it by 2 using the ratio. Right, so now that I've used my ratio, it's 0.217, but I'm keeping it on my calculator of Na2O. Now, step number 4. Get out of moles. Number of moles times by rams will give me grams. So all I need to do is work out the weight of sodium oxide. Sodium, of course, is 23.0, and there's 2 of them, plus oxygen at 16.0 times 1. So I need to remember that number on the calculator. I've got to be careful that I don't lose that. Yeah? I can't remember how to store it. I can't remember how to do this. Oh, no. Oh, no, I've lost it. I'll do it separately. 23 plus 23 plus 16. 23 plus 16 gives me 62.0. 62.0 is worth a mark. Right, that goes down here, 62.0. I'm now going to have to run this calculation again, all the way through, in fact. 10 divided by 23 gives me that moles. Divide that by 2 gets me that moles. Times by, right now I've got that number, 0.21739130004. I'm laughing because I'm not listening to some of Miss Allday's techniques. I'm not listening to some of Miss Allday's. Let me keep going without deleting any methods. I don't know what methods it is that she's taught you, Adam. I'm assuming it's a table method. I don't like it. I'd have to see what you're doing to make sure you're scoring all the marks. You need to show the marks are going to be for the moles of that guy, those 2 numbers written down as a ratio, those moles there, yeah, and 62 and the final answer. So I'm going to times that by 62 and I'm done. So the answer finally is 13.5 grams, and I'm done the table. Yeah, delete that. Delete. That does happen, Adam. I do quite a lot of having to reteach stuff. Yeah, I just have to delete bits and pieces. She does the same thing. Yeah, because the calculation is worth method marks now. Right, so guys, I just want to quickly, now that I've gone through that method, I had 3 learning objectives on my YouTube channel account. I'm just going to quickly put those up here anyway. I'm also aware that I'm running out of time. I think, in fact, have I run out? No. It runs out at 12:10. Yeah, I've still got a while yet. So I need you to know the steps. The learning objectives for today was, number 1, I need you to know steps in reacting mass. I'll just put RM, Rick and Morty. Next, I need you to understand mole ratio. Yeah, and how to use it. Yeah, right. The next one is understand multiple equations. Right. So I'm going to have a go at that one now. Multiple equations. And then the last one is just be able to do exam questions, exam Qs. Be able to do exam Qs. Okay, so I want to show you now multiple equations. So the problem is with A-level is everything just gains this extra level of complexity. So how does this now evolve to an A-level question? Well, what they're going to do is something akin to this. So I'm just going to quickly run through with you guys just something called the contact process. Now, the contact process is the making of sulfuric acid. Yeah, that's what it's done. And I'll show you all the equations for it. They buy sulfur from people who mine sulfur from volcanoes. and they react that with oxygen. That burns blue to form SO2. And then SO2 is reacted with more oxygen to form SO3. Let's balance that equation. Yes, you can now balance with a half. Did you know I nearly wet myself when someone told me that? I was like, oh my God, I can use halves. Absolutely amazing. So now we've got to, by the way, and that equation actually is reversible, not that it makes any difference. Then we take the SO3 and we react that with sulfuric acid, which seems awfully bizarre, doesn't it? And what you form is what's called oleum, H2S2O7. This is called oleum. Scary stuff. Fuming sulfuric acids. Well, scary. It's like woza. Yeah. And then what you do is you take oleum at H2S2O7 and you add water to it and you form 2 sulfuric acids. So that's actually how they make sulfuric acid in industry, which is rather interesting. And here's what I'm now going to say. So I'm going to now say to you that you are given, and the problem is this equation actually is not a particularly useful one. I suddenly realized this isn't one that's actually any good at this. Yeah, but I'm going to do it anyway. I'm going to give you 100 grams of sulfur. And how much sulfuric acid am I now going to make? So this is now just me doing, this is multiple equations in reacting mass. And the great thing is you don't need to worry about it. It just requires a little bit of understanding. So what everyone would here agree with, the first thing I can do is I can calculate moles of sulfur. So number of moles is grams over rams, get to moles. Yeah, and I've got 100 grams over sulfur. Sulfur weighs 32.1, I believe. See, the problem is, you see, you've got to be careful with A-level because I've got a whole lot of decimals in my head. Sulfur, 32.1. There we go. So over 32.1, that's going to give me moles of sulfur. So 100 divided by 32.1 gives me, right, so I now have, going in here, I'll do this in green, I now have 3.11 moles of sulfur going in. Right, now we need to walk all the way through the equations with that number. The ratio here is a 1 to 1 to 1. Well, where does the SO2, the SO2 is my only product here. So the great thing is that there is a 1 to 1 equation. So I'm going to make, as a result of that first equation, 3.11 moles of SO2. Now here's the neat bit. That number now gets copied over to here because that's what's going in the next step. Yeah, people often hate is if I had doubled this equation here, I could have doubled it. Actually, it would have been better to do so. Yeah, let's double this equation. Duh and duh. Yeah, people think if you go from here to here, that you're using another mole ratio. This is not the case. The SO2 you make over here just slides straight into the second equation because there's no reaction that's happening between these two. You're just picking it up and putting it into the next one. So that number there copies straight over to that one. If you ever move between equation, the number stays the same. That's all. That's the rule. So the rule is if you're moving, nota bene, moving moles between multiple equations, don't change mole value. It doesn't really make a lot of sense that. It's hard to really put that into words that actually makes sense without the actual example. Yeah, but if you're ever moving between equations, moving between the levels, you never change them. Right, now, the only product in this step here is SO3, and that's in a 2 to 1 ratio. That's in a 2 to 2 ratio, which means the number is still the same again. Right, I don't change the number between layers. So this number now comes back down to here at 3.11 again. Right, the only product here is oleum. It's a 1 to 1. Yeah, it's a 1 to 1 ratio. So that now becomes 3.11. And then that number now transfers without changing to the next level of the equation to 3.11. And now the ratio is finally a 1 to 2. We divide that number, times that number by 2. And I now get 6.230. And those are my moles. And it asks me for mass multiplied by 98, the MR of sulfuric acid, multiplied by 98, and I get a mass of 610. 11 grams to 3 sig fig. I'm done. So That's all I wanted to mention, is this idea of chopping between equations. They do this quite regularly at A-level. They have these 2 or 3 steps. They never go up to 4. That's just stupid. And most of the time it's just 2 in reality. But I do need you guys to get yourselves into good habits of being able to know how to do these. Okay, the next thing with reacting mass. So how does it change? What does A-level reacting mass look like? So number 1, you're going to have to write the equation. Yeah, A-level reacting mass. Reacting mass. Number 1, write equation. That you will need to do. Write equation, and don't forget to balance. It's usually the mistake. Yeah. The next thing is you're going to use multiple moles. Yeah. Chances are, yeah, multiple moles equations. Multiple moles equations. Students go, I don't quite understand what you mean by that. What that means is, in the question, they're going to say something like, let's go back to, let's do sodium and oxygen again. Why not? Let's go for sodium and oxygen again. What they're going to do is they're going to give you, they're going to give you 10 grams of that and ask you for the volume of oxygen needed at STP. That's what they're going to do. So what you realize is you have to here use grams over rams, but here you're using PV equals nRT. It's not complicated. You've just got to realize that these equations, you can move between them succinctly. You know, they all get you to moles, and so they're just going to combine them. It's not actually as difficult as you think. Yeah. The next thing is they're probably going to rope in a percentage yield. Yeah, percentage yield addition. Yield addition. Oh, and possible sampling. Sampling, that's a nightmare. So they're just adding these levels of complexity. Multiple moles equations, yeah. Oh, multiple steps. We saw multiple equations. Rather than moles equations, just multiple equations. Yeah, this is what they're doing. It's just this general increase in level. Now, what I'm actually going to do is I'm going to end the lesson here. I've been going nearly an hour anyway, and I know that I'm not even meant to. Oh, no, hang on. One more sec. Give me 1 more minute. 1 more. I want to show you the questions. Yeah? So let me show you what these look like. And I'm not fiddling this at all. I am literally going to just go to my backup files. I'm going to find my booklets, pen drive. I know that says use booklets, but it's not really what I want, to be fair. Oh, no, maybe it is. AS. I just know the AS better than at Excel. Sorry, that's why I've gone for that. Amount of substance, booklet questions, and the booklet's bigger, so I can kind of show you this in action. Let's see if we can find all of those additions that we just said. Okay, look at question number 1. A sample of nitroglycerin. Oh, there's the gas question. I just took the bit of gas out of this bit. Yeah. They've given you grams. So in this question here, folks, they have given you grams and then asked you to work out the volume of gas. So they've moved between grams over rams and PV equals nRT. Not complicated. Let's look at the next one. Straight gas calc. Empirical formulae. Balance equation. Grams over rams going into PV equals nRT. I'm trying to find another one. Okay, there, look. Calculate the volume in centimeters cubed required to react with 1 gram. Grams over rams, C times V over 1,000. They're just blending them together. Yeah, I'm trying to find a good sampling one. There's another gas equation. I should really do some examples now at this stage to get you guys used to it. Wowza, that was a big question. Big question. I'm trying to find one with multiple equations. I'm looking for them. I'm looking for particular types here. You realize that most of them are somewhere in the middle in terms of difficulty. I think that one had multiple equations. The BAO then goes back in. Yeah, you see second equation. That's quite clever. There you go. And mixture of grams over rams. So we have a go at this one, guys. I seem to. Oh, you guys have all gone quiet, and I'm down to 4 watchers. So I'm going to leave it there at this point. Guys, I will set you a homework. You know what I'm going to do. I'll set you a homework. I'm down to 4 watchers, so I'm definitely going to end it now. Right, guys, I will set you a homework for this for the weekend. Enjoy your weekend, and I'll see you guys soon, I hope. See you later, guys.